Here we have a SAT math question. Okay, let's go to the information. There is a table of values given for x and g of x, and there is a function given over here. There is g of x equals to f of x or x positive 5. The table shows the x and y values for the function g of x. The function f of x is an exponential, and the exponential function in the form of a times b to the x power. What is the value of a positive b? Okay, we have g of x equals to f of x or x positive 5. And we have the stuff which is equivalent to f of x, because f of x is an exponential function in the form of a times b to the x power. So here this f of x can be replaced by a times b to the x power over x positive 5. Okay, now in this function g of x, we have to find the values of the constants a and b, so that we'll be able to get the value of a positive b. So for that, I'm just going to use the values we have on the table. That is, when x is equal to 0, g of x equals to 0.6. Okay, let me plug in x equals to 0 into the given function over here. Then I'm getting g of 0 is equal to a times b to the 0th power over 0 positive 5. And the value of g of 0 is 0.6. That is, g of 0 is nothing but the value of g of x when x equals to 0. So that is 0.6. So we can plug in 0.6 for this g of 0 and equals to a times. So the value of b to the 0th power is just 1, because anything to the power 0 will result 1. Over 0 positive 5 is 5. So 0.6 equals to a times 1 is a over 5. Okay, to solve for a, I have to multiply both sides by 5. When I multiply both sides by 5, 5 times 0.6 will be 3. And this 5 will cancel. I'm getting a equals to 3. Okay, now I got the value of a. So still I have to get the value of b, so that I'll be able to get the value of a positive b. Okay, first let me plug in the value of a into the function over here. That is, for this a we have to plug in 3. So then the function g of x becomes 3 times b to the x power over x positive 5. Okay, now our aim is to get the value of b. For that, I'm going to use a second point. That is, when x equals to 3, g of x equals to 24. Okay, now let me plug in 3 for x into this function over here. Then I'm getting g of 3 equals to 3 times b to the 3rd power over 3 positive 5. And also, when x equals to 3, the value of g of x is 24. That is, g of 3 equals to 24. Okay, let me plug in 24 for g of 3. 3 times b cube over 3 positive 5 will be 8. Okay, now to solve for b, we have to isolate b. So for that, I multiply both sides by 8. When I do so, this 8 will cancel. I'm getting 8 times 24 equals to 3 times b cube. And let me divide both sides by 3. So then this 3 will cancel. 3 goes into 3 one time. 3 goes into 24 8 times. So then 8 times 8 is 64 equals to b cube. Okay, now so we have to solve for b. So but here b is having exponent 3. So now we should try to write this 64 as a power with the exponent 3. So that is a 4 cube. So when I evaluate 4 cube, that is 4 times 4 times 4, that's equals to 64. So 64 can be written as 4 cube, and on the right side we have b cube. So here two quantities are equal with the same exponent. So whenever two terms are equal with the same exponent, we can equate the bases. When I equate the bases, I'm getting the value of b. So that is the value of b equals to 4. Now I have the value of a and I have the value of b. So now I can find the value of a positive b. So a positive b equals to, now we can plug in 3 for a and 4 for b. Then we get a positive b is equal to 3 positive 4, which is equal to 7. So finally, I got the value of a positive b. So the value of a positive b is 7.